Warm welcome everyone for 6G versus webinar, 6G vertical trials for sustainability from vision to 6G trials. I'm Sanna Tuomela, project coordinator from the University of Oulu, Finland. And this is the first webinar in a series of 6G versus webinars that we will organize. And today we have 1 hour webinar. First, I and technical manager Xenophon Vasilakos will briefly present the project. Then our use case leaders will show you the pilots, 6 pilots we have in different countries. Then we will have a slot for discussion. If you have questions before that, please put them in chat and we can then discuss them in that point of webinar. After discussion, our new 6G Venture Accelerator program and 6G versus training program will be introduced. And finally, we will have a glance at the next steps. We will record this webinar, but we will pause the recording during the questions and answers, that is the panel discussion. Let's have a look at the project facts. 6G versus 6G vertical trials for sustainability is a 3-year SNS JU funded project. Stream D, which means that we will have large-scale trials and pilots with verticals. Funding is about 12 million from SNS JU and total budget 14.5 million. We are now approaching midterm and we have some initial results from our pilots that we will see today. We have 34 partners from 10 countries, of which 13 are academic or research organizations, 10 industrial partners, 9 SMEs, and 2 NGOs. Verticals are verticals and industry. They are very well presented among our partners. We have 5 high-level objectives in the project. First, we design and develop a 6G-enabled application framework for the triplet of vertical app, AI app, and network app. Secondly, we conduct trials to assess performance of these applications, concentrating on the principles of sustainable 6G. Thirdly, we have 6 test beds, and we integrate the applications on those test beds. Test beds are mostly from previous SNS projects, but one of them is non-SNS test bed. Fourth objective is to assess societal and environmental impact and also to introduce new business models for 6G application in verticals. And then finally, we maximize the impact and adoption of our results through dissemination, communication, capacity building, standardization efforts, and exploitation measures. And technical manager Xenophon Vasilakos will continue from here.
Thank you, Sanna. First off, can you please verify that you can hear me?
Yes.
Good, thank you. You should be seeing on your screen my slides. I also welcome you to this event, this public event today from our project 6G Versus. I'm the technical manager of 6G Versus on behalf of ICCS Athens, Greece. Now, this is going to be as much as possible within the next 5 minutes, a technical introduction to what we do. As Sanna said, we have 6 sites where we're running 6 different pilots in those 6 countries that you can see on the map. I'm going to start now going through each and every one of them from top to bottom. We start with the Finnish pilots, which is in the University of Oulu in Finland. The common thing amongst all these 6 pilots is that they relate to sustainability. So we start from Finland with an energy self-sustainable 5G base station, which is being studied there and demonstrated. Then we go to France, that in fact we got 2 use cases, not just one, related to one another. One of them is targeting data-driven strategies for fresh water management, and the other one on waste water management for critical infrastructures. As we go more in the south, we go to Portugal. That's the pilot over there targets environmental monitoring and safety for sustainable and safe ports. In Spain, we got a pilot which targets smart agriculture through immersive telepresence actuation for field operations. And last but not least, we got a pilot in Greece on life-saving environmental preservation that uses collaborative robotics for search and rescue and for fighting forest fires. Now, if we see things from a more technical point of view, what all these pilots have in common, as you have already understood that they are quite diverse, what they do have in common is the common approach that we have into what we call a 6G application in our project. A 6G application is composed of 3 different sub-applications, all of them bound together into a 6G application with interfaces with one another. We start, of course, with the vertical application, which is what traditionally is the service that offers domain-specific context awareness of what the use case is about. Then we have the network application or NetApp or NApp, excuse me, which lives in the border between the network and the user space and is offering direct access to network functions that lie at the core of the network. Therefore, with the 6G application, we managed to bring together both the service offering context awareness, but also the network itself. So the network adapts to the service and the service can adapt to the network to get the best out of the 2 worlds for the performance of the service. And the third part is the AI part that comes with the AI app. This is offering, besides the usual machine learning analytics that you would be expecting from this component, also the, as we say, the ability to transform raw data into actionable intelligence, both at the service space and the network space at the same time. So you could be, for instance, orchestrating your service level resources, but at the same time, you could be doing the same thing by having knowledge of the network resources. And this is just one example. And given the fact that we don't have much of the time, this is the general architecture that basically depicts what we explained earlier. We start with, on the top side, with the vertical applications and then the AI applications, all of them communicating with one another from specific interfaces. Here, this is depicted as a bus of exchanging data. The network applications also, the one or more network applications, they work together with the AI apps, the one or more AI apps, and the one or more VApps that you have in your system by exchanging data through these buses over here. And then here you can see in a little bit more detail how the network application that, as we said, lives in the boundary communicates with both network functions through CAPIF and the AI and the VApps. Now, this is a general architecture. It doesn't show you exactly how it is adopted by all of the sites, but this is what is being adopted as a general concept and tailored for each specific site. Besides this, you can see that we have taken provision for machine learning operations, MLOps, as you can see here, and how they are being considered in our high-level reference architecture for the AI app part, giving you more than one options depending on the case and the needs of the AI apps and the local sites and use cases. As previously said, we also have considered AI service orchestration, AI-based network resource orchestration and management. As you can see, all of the layers here, they are spanned through the energy efficiency requirements. And then, of course, we've got the infrastructure monitoring, which happens from the network application side and lower all the way to the actual infrastructure being utilized in each and every site. And just to recap in this very short and very brief technical presentation, we have 10 technical admissions, very deep ones. One of the things that we do is that we work on the project on NApps so that we can have integration with the network core. We have a transformation of all the vertical services, traditional ones, into VApps and therefore into 6G applications. We have energy efficiency studied as a service so that it can be given to the 6G applications as a service from the network. We got the machine learning enabled continuum from the central cloud all the way to the far edge. We got expanding connectivity and coverage with UAVs acting as basically mobile base stations when needed. RedCap technology, low latency deterministic communications, two-step rack, which is a technology utilized for IoT sensors in all the use cases that use it. We got end-to-end protocols for precision agriculture, and we got ORAN, Open RAN, intelligent controller towards reduced energy consumption. These are 10 core technical ambitions. They're not the only ones in the project, but these are the critical ones that we are working on. And having all that said, I think that I can now pass the talk into the next presenter. Thank you and welcome to this presentation from our project.
Thank you, Xenophon. Now we'll hear about our pilots, and first is Bulgarian pilot, and Ralitsa Rumenova from Entra Energy will present that.
Hello, everyone. Do you see my screen now?
We see it. Please put it in the presentation.
Yeah, just give me a second because I've tested it and still I have some difficulties. Just one sec. Give me a second. Oh my God.
They are on the bottom bar.
Yes, I know. I was just... Okay, now it should be okay, I guess.
Yeah.
Yeah. Okay, my name is Ralitsa Rumenova from Entra Energy. I'll be presenting the Bulgarian pilot on behalf of the partners in the pilot. So the vertical challenge that we address. The energy systems undergoes a dramatic change in the recent decade, moving from centralized, predictable and easy to control to technologically diverse, dynamic and complex. The share of distributed energy resources increases exponentially, and most of them are small to mid-sized, geographically spread in remote areas outside reliable telco coverage and are not monitored remotely in real time. This implies tremendous challenge to the grid stability and control and leads to situations like the blackout in the Iberian Peninsula in April 2025. So the situation calls for significant investment in fully digitalized infrastructure and in flexible distributed resources. And that's the challenge that we address. Remote renewable assets today deliver energy only because the poor connectivity prevents them for the grid operators from trusting them for broader set of services. So by combining 5G real-time communication with AI-driven monitoring, the distributed energy resources become active grid participants. AI-driven wide area monitoring and control of distributed energy resources has the role to detect early warning signs of grid disbalances and provides coordinated response options to both the distributed energy resource owners and to the grid operators. This unlocks flexibility, resilience, and economic value for all. This smart grid pilot requires beyond 5G capabilities to support reliable, low latency, and secure communication for critical grid operations. So the pilot leverages advanced technologies as network slicing, edge computing, AI-driven analytics and monitoring, and of course, reliable coverage availability in rural areas. The pilot testbed involves actual energy resources, digital grid emulation and digital twins, connected all by AI-driven applications like to the telco infrastructure. It is important to mention that the Bulgarian pilot runs on live production 5G standalone network of A1, alongside with other like couple of millions customers. So for the pilot, A1 should provide reliable network coverage in a rural area where the wind turbine of Entra Energy and the rest of the energy infrastructure resides. And this remains one of the main challenges for advanced connectivity services, particularly for beyond 5G smart grid use case like Bulgarian ones. This simple flow diagram shows how the pilot actually works. So on the left-hand side, we have the phasor measurement unit sensors that are installed on medium voltage level. This is an innovation because these kind of sensors are very typical for high voltage, but could not be found on medium voltage level. So they're sensing in very high granularity, like in millisecond granularity, the power parameters of the point of interconnection of the distributed energy resources to the grid, and they are the eyes of the system. The central vertical application that is part of the 6G triplet acts as the brain of the system and analyzes the information, makes AI-assisted anomalies prediction, and in case of an imbalance is sending corrective set points for execution to the regional controller that are the remote hands of the system. The regional controllers are aware in real time about the status of the distributed energy resources under management, like in our case, the current production parameters of the wind turbine, the parameters and state of charge of the battery energy system. And based on the available flexibility, regional controllers, the remote hands, are sending control actions for execution to the distributed energy resources, who are the muscles or the actuators that provide the requested support to the grid. The green rectangle is the wide area monitoring and coordinated control simulation that is performed in University of Cyprus lab, while the actual Bulgarian pilot and test bed is shown in the red dotted rectangle and shows the element of the Bulgarian pilot and test bed. It is important to emphasize on the importance of the beyond 5G connectivity to secure the fast and low latency communication in close to real-time manner. And just to give an example, if a PMU measurement arrives with more than 40 milliseconds delay, it will be disregarded for the prediction of the frequency. So given the technical and legislation complexity of the pilot, the pilot integration is phased in 2 phases with 2 trials in each phase, so altogether 4 trials. The first trial aims at evaluation and establishment of the baseline connectivity and service workflow test in the remote area where the pilot site is situated. This includes secure G-node bit coverage to the rural area of the actual pilot's location, selection and deployment of the PMU sensor on the pilot site, open CAPIF integration and vertical application, integration, validation, and deployment on A1's cloud. Here are some pictures from the pre-trial and trial run activities. Pre-trial activities were performed in A1 and Entra Energy Labs, and on 26th of March in New Bulgaria University, the first trial activities were presented to external stakeholders from academia, SMEs, telecom, energy, and ICT domain. Target KPIs were assessed through questionnaires, and the responses were analyzed as very positive toward the pilot's delivery to the targeted KPIs in this trial. The second trial is a digital twin, hardware in the loop simulation to recreate the real grid behavior for safe pilot testing and validation within the pre-piloting testbed of University of Cyprus. This event aims at a full end-to-end data flow demonstration from sensors monitoring a power grid to a digital twin replica of the power grid, 5G communication path, up to the ancillary service delivery by the distributed energy resources from below high voltage in the system, thus closing the control loop for the innovative 6G-enabled wide area monitoring and control service. The second trial event will take place on 11th of June at University of Cyprus, Chios premises, and will engage external stakeholders from SMEs, DSOs, TSOs, electricity market operators, research and academia community, telecommunication and ICT domain. The live trial 2 demo will use state-of-the-art facilities, Opal RT Smart Grid testbed, open air interface, 5G-like testbed, and a dedicated GPU server hosting the MLOps framework. And the pre-trial activities and dry run tests for the second trial took place at University of Cyprus lab and were performed by a highly skilled interdisciplinary team of researchers in power system, in telecommunication, and in ICT domain. These are the key KPIs and KVIs that the project has targeted. And as initial results and lessons learned, I can summarize that the XAPS and PMU-based monitoring are successfully validated in the laboratory environment. Stakeholders' feedback confirmed positive impact across target KVIs. And from the lessons learned, we saw that the attendance is a challenge, and that gathering all stakeholders groups, for example, telco and energy expert together in one single event can be challenging, even though we have achieved it somehow. More focused demonstrations may support deeper discussions and more valuable feedback. We also learned that while online questionnaires work well for broad feedback collection, the concern is that complex or too long questionnaires may discourage especially senior experts from completing them. So for the second trial, we consider a shortened questionnaire and interview style approach. So that was it. Thank you very much.
Thank you, Ralitsa. Now Hamid Malik from the University of Oulu, Finland, will present the Finnish pilot. Please, Hamid.
And if I may add, to keep the presentations a little bit short in order to be according to the timing of today's agenda.
All right. Hello, everyone. Can you guys see my screen?
Yes.
Okay. My name is Hamid Malik. I'm a doctoral researcher at University of Oulu, and I'll present the Finnish pilot and the use case. So our Finnish use case is the energy-aware architect remote site with AI-enhanced control. So we have the use case, which is the energy self-sustainable base station site, and which focuses on a grid-free remote radio base station site, which completely operates without the need for an electrical grid. It relies on renewable energy sources like solar and wind. And for the backup, we use the backup batteries and hydrogen fuel cell as the last resort. So all the components you can see in the use case diagram are managed using a central controller, which is the brains of the system, and it's connected using a microwave link using a wireless front haul. University of Oulu in the 6U Versus project is responsible for defining the architecture, design, and the implementation from the hardware perspective and from the software perspective using all the components. So our use case will evaluate the operation for 1 year and starting from June, and then we will have 4 trials. Each trial will be used to validate the solution feasibility in the harsh Arctic weather conditions. This is our testbed. So you can see that our testbed is divided into 3 parts. We have the far edge, which is the remote radio site. We have the remote radio unit, the microwave link, and the intelligent controller. All the components are powered using the renewable energy sources. Then we have the 5G system, which is there we have the network intelligent controller, and we have the O-RAN system. And then we have our 5G test network in University of Oulu, where we will use the triplet application. So this is a distributed network architecture, as Xenophon mentioned, and we have the VApps, NApps, and AI apps working together. That's what makes it 6G. And so all the apps are running inside the central cloud, which is the inside the server. So the vertical apps will be responsible for the web-based dashboard, and the user interface, where the user can create an account, and we will see the real-time monitoring of all the components regarding the production from the solar and wind, how much we have the consumption for the microwave link and all the components at the remote side and at the network side. And we have the forecasts, which will be used for energy budgeting scenarios. So there is a trial lifecycle management, which is handled by the vertical apps. Then we have the network app, which is the data plane application, and it's responsible for storing all the components data from the XApp, AI apps, and the remote side. And then finally, the AI apps, which are the brains of the system. So AI apps are working together. They are divided into two parts. We have the AI app 1, which is the Architect energy control. And then we have the AI app 2, which is the Architect traffic control. So Architect traffic control predicts the traffic profile, how the next hour throughputs look like. And based on that, we'll adjust the RAN configurations from the OA box. And then the Architect energy control will look into the Finnish Meteorological Institute for the next 66 hours and will predict how the energy weather availability looks like, and then adjusts all the components based on the energy budgeting scenarios for the next hour. So we have the trial plan, and then in the trial 1, we presented the energy budgeting simulations, where we have the hardware architecture and the software architecture and the MATLAB simulation-based energy budgeting for the entire year. And the stakeholders were presented with the idea of how the 6G architecture and this off-grid 6G base station site works. The idea was to assess their perception. Is that clearly understandable? What's the value behind it? What problems it solves? And then also to see the impact, what kind of socioeconomic and environmental impact it will be creating, because it's completely relying on renewable energy sources, and it can be deployed on areas like Arctic parks where the traditional grid is quite challenging. So it's an environmental net positive sites, and it takes care of matrices like sustainability matrices. So we try to identify the stakeholder priorities and the barriers of what matters the most. So some of the results based on the trial 1 are presented here, and you can see that all the stakeholders actively participated in the questionnaire. So the KPIs and KVIs are listed here, and the most important KPI for the Finnish use case is to keep the remote radio site operational for the entire year. And for that, we have the hydrogen fuel cell and the backup battery. So of course, in harsh Arctic weather conditions, there are days where 90 days of no sunlight, and weather conditions are quite extreme. So for that, the AI apps will work together along with the intelligent controllers to make sure that the site is operational. Then certain KPIs regarding energy efficiency, regarding the self-sufficiency of the remote site. So we'll measure the power supply losses and how much the hydrogen fuel cell was used, because the idea is to adapt the RAN configurations and the energy availability in a way that we don't use the hydrogen fuel cell quite oftenly. So then the 2 KPIs will measure the cost counter and the reduction of CO2. So for the cost counter, we'll measure the electricity pricing against the how much renewable energy was produced, and based on that, we'll calculate how much energy was saved instead of using the grid energy. And then similarly for CO2 emissions in Finland, we have the FinGrid providing us with the CO2 emission estimates. So we will use the CO2 estimates for the grid link grams of CO2 per kilowatt hours, and for that we'll use the reference from how much CO2 would have been linked if that energy that we use from the renewable energy sources was used to power up the remote site. Then sustainability KPIs are quite very important. As we said, that this use case is targeting towards the Arctic Park and the conditions where it's quite challenging to have the traditional electrical grid. So, and how much renewable energy was used, how much reduction in the waste energy, and then the reduction in the consumption in the remote site. Some of the expectation and the outcomes. So we'll perform these test cases as listed here, and these will test the resilience and reliability of our use case. We'll also measure the end-to-end technical performance, all the parameters, when is the AI app activating the hydrogen fuel cell and the dynamic battery management system. So all the components will be tested, the energy efficiency will be measured, then the energy profiling for 1 year will be documented. We'll do the sustainability assessment, and finally we'll work how much AI that gave us these energy budgeting solutions, the accuracy of the assessment. The expected results will make sure that the system ran for the entire duration without any interruptions, and all the functions were keep running, and then the system related configurations and measurement data will be stored. So all the AI-based suggestions will be stored, and after 12 months, we'll have that data publicly available for others to use. Thank you so much.
Thank you, Hamid. Then Alexander Boudon from Green Citizen will present the French pilot.
Thank you. Can you hear me?
Yes.
And do you see my screen?
Yes, we do.
Okay, great. Okay. So I'm presenting the French pilot, trial one for smart watering use case. And I'm one of the co-founders of Green Citizen. So before starting, let's review what do we mean by smart watering. So we are talking about watering of public green spaces, and smart watering is a four-pillar kind of approach. The first one is to get connected irrigation to control remotely the irrigation. The second one is to manage an agronomic watering irrigation. That means that we deploy some sensors to collect the need of water from the plants. The third one is to manage a self-regulated watering. We do not water until this is mandatory. And the fourth one is to supervise the hydraulic network to detect hidden leaks. So during the trial one, we are going to show the VAP following items. So we build some environmental indicators dashboard. We detect some abnormal watering. How do we detect some hidden leaks? And we demonstrated that the B5G connectivity was okay. So we deployed the solution of smart watering in 2 parks in Marseille, Parc de l'Oasis and Parc Bortoli. The smart watering solution is composed of 3 key components. The first one, as I said before, is soil sensor at the root level of the vegetation. Then we have an electro valve controller to manage watering, and we have a water meter at the primary network to detect some leaks. So that's what we deployed. And we see here a map of one of the parks we deployed the solution. So we can see some soil sensors. So here is the transmitter with the connectivity, and it's plugged into the sensors at the root level of the vegetation. We can see here the electro valve controller. So our device is controlling the electro valve, the solenoid that we can see in here. And we also monitor the water flow at the primary network. So one of our objectives is to provide environmental indicators. So environmental indicators are contributing to 5 objectives, finally. Is for sustainability reporting, ESG performance monitoring, certification program, subsidy and grant justification, and also ROI evaluation. So finally, environmental indicators are contributing to water conversion policy, energy efficiency strategies, and climate action objectives. So it's not a single contribution, it's a multiple contribution. So in here, we can see that now we are able to display the water savings in meters cubed and the leak detection also. So we have the contribution of the system in terms of meters cubed. And then we are able to also look at this over time to feed a continuous improvement methodology. This water savings occur some CO2 emission decrease and also energy savings. So we can also valorize these contributions. The system is continuously comparing the scheduled watering, the effective valve opening, the soil moisture measurement, the climatic conditions, and the irrigation instructions. So that's why we can easily flag some issues like too much watering despite enough soil moisture, malfunction irrigation, repeated irrigation due to communication loss, irrigation despite saving expected, and inactive device preventing proper regulation. So here is an example of one issue raised is too much watering on this kind of park. We also are able to detect some leaks, so it's very easy. We look at the water consumption at the primary network each hour, and apart from the scheduled time of watering, we should have 0, and if not, we can raise this alert. And finally, here is the demonstration of a soil moisture transmitted its data using the B5G connection. This device has been deployed at Eurecom test bench in Sofia Antipolis, and the data chronology confirms the reliability and the continuity of the communication link. Here we can see all the data transmitting properly. So this validates the suitability of B5G connectivity for smart watering to be able to optimize watering decision and improving resource efficiency. That's all for me. Thank you very much for your listening.
Thank you, Alexandra. Then we have George Makropoulos presenting the grid pilot.
Yes, can you see my screen?
Yes.
Okay, perfect. So hello, I'm George Makropoulos. I'm a research engineer at NCSR Demokritos. And as the leader of the Greek cluster, I will present the activities that we have performed so far. So actually, I will start by briefly presenting the motivation behind the Greek use case. And this is actually a very timely moment as we have entered the summer period, and the topic of wildfires is highly relevant. So within the Greek use case, and having in mind that the wildfire events require fast and coordinated response, we focus on how to improve the emergency response in such conditions. And we also explore how robotic drones, AI, and beyond 5G connectivity aspects in general can work together to reduce human exposure and at the same time to improve response times during search and rescue activities. And the partners that share these efforts in the use case are ICCS, Demokritos, OTE, Infolysis, and HRTA as the end users. So here you can see in this slide the high-level sequence of the steps that shape the scenario that we are targeting. So initially, there is the early detection of the smoke that is achieved with a camera and AI algorithms at the back end, which triggers the first alert. So the next step is to check the area and the area that the smoke was detected to identify potential victims. This is achieved with the capabilities of the 5G core and the APIs that it offers. So we have the location of the device,
And then through AI processing, we predict if a victim is located in a dangerous cell, and I mean the cell that has been correlated with a fire. Subsequently, a drone is performing an aerial assessment, and in parallel, a robotic dog is performing a ground assessment. And in order to have an operational continuity in all this process, another drone acts as a relay link for the robotic dog in the case that there is the need to search in a wider area, for example, so the dog needs to go to another place. And in the end, all these steps are to support the rescuers and to ensure safer and more effective operations in general. So here, moving to the next slide, you can see some features of the testbed that we are using to demonstrate the scenario. The testbed is spanned across two interconnected sites, so we have Dimokritos and Tote. So in this way, we can share resources, and at the same time, we provide a variety of both, let's say, research and commercial grade technologies. At this figure here, you can see the area that the trials took place, and also some main components such as the two antennas, the camera, and that have been used during the trials. On top of that, we have the additional Beyond 5G components as part of the use case. For example, the AI processing at the edge. We have efficient energy as a service capabilities, and of course the connectivity aspects between the robotic dog and the UAV. And here you can see a component level architecture of the Greek use case and how let's say this triplet that we have been discussing previously, that was presented previously by Xenophon, and how our application shaped the Greek use case. You see that the majority of the components are deployed at HCSRT side. We have the AI backend part at OTE, and you can see here all the applications that we are developing. So in order to save time, I won't spend more time in this slide. And actually now moving to the actual trials, just to say that we have recently concluded the first round. The initial trials took place in March, early March, and it was actually a way to make a proof of concept for the interconnection of the system, all the components, and we did it in a more static approach. As I said, we wanted to test the interconnection first and then move to the subsequent phases. From a technical perspective, the goal was to validate parts of the 6G application. And then from a business perspective, we wanted to shape the initial logic of the early wildfire detection scenario and to identify its operational value. Some nice figures here. And then moving to trial number 2, the second trial again showcased the same approach. However, now it was a more operational approach. We had mobility now we had mobility for the robotic dog, and also there was the testing of the drone acting as a relay link. From a technical perspective here, as I said, with these trials, we wanted to validate additional 6G application interfaces. So we had the clear delta from the initial one. For example, we tested two-cell capability in this case. And from a business perspective, the objective was to demonstrate the scenario along with a ground level assessment. So, to pave the way as we move to the next phase and test the end-to-end scenario. And of course, since 6G Versus is a StreamD project, the use case is and should be complemented by a set of KPIs and KVIs. So in this slide, you can see the list of KPIs targeted for the first round of trials. So as you can see, we include application level KPIs. We also have network KPIs, as well as metrics that are related to energy efficiency and AI performance. And within the project, we also carry out an exercise to map these KPIs to KVIs. And we try to capture both environmental and societal impact dimensions with our use case. And finally, looking at the lessons learned from trial 1 and trial 2, I have highlighted some key points. First of all, the important thing is that we achieved successful integration of the components. We had a smooth interaction, so we managed to demonstrate the triplet functionality without any major technical issues. Of course, several improvements have been identified and will be further validated in the next phase. Secondly, the trial setup was demonstrated in a successful way, and this was actually a feasibility test in order to move to the end-to-end implementation. At the same time, we identified several areas for improvement. So these were mainly related to the operational flow and how the scenario should be structured and presented to the stakeholders. Because we want to highlight the added value, so we need to find a proper way to demonstrate the scenario and at the same time to share the overall logic. And one thing that I should highlight is that the stakeholders' engagement proved to be quite challenging, meaning that even though there was a structured approach and we did it in a proper way, we need to make sure that in the next phase we will have stronger participation in order to have some meaningful results and to collect valuable feedback. And during the trials, we had a variety of audience. First of all, in the first trial, the audience were mainly from the research and academic community. There was a participation and there was significant interest in the overall scenario and mainly in the technologies. While during trial number 2, the audience was expanded, including academia, SMEs, as well as representatives from the public sector, for example, municipalities. And we collected valuable feedback. For example, the municipal representative showed a strong interest. We had discussions how the scenario could be adapted to other activities, and we also discussed some operational challenges regarding the use case. So that's it from my side. Thank you for your time, and I give the floor to the next presenter.
Thank you, George. And the next is Sergio Figueiredo from IPN, who will present the Portuguese pilot.
Can you see my screen?
Yes, now we can.
Okay, thank you. Okay, my name is Sergio Figueiredo. I'm from IPN in Portugal, and I'm here to present the Portuguese pilot. The Portuguese pilot is focused on the maritime port needs, and it addresses advanced monitoring capabilities leveraging beyond 5G and 6G for different needs, spanning environmental quality, safety, and obviously, given the project scope, energy efficiency and sustainability. So in particularly, we are addressing the upcoming environmental regulations and targeted SDGs from the port perspective. The use case is addressed via 3 different scenarios, each focusing a specific vector or need. The first scenario addresses port environmental quality, and particularly water and air quality from an early warning and early source detection point of view. Scenario 2 addresses port safety, particularly the identification of hazard material trucks and their entry in illegal zones. And finally, the third scenario addresses infrastructure energy management, particularly from the point of view of optimizing the usage of renewable energy. So in such contexts, there are specific communication-related requirements. Some of them include massive or the need to support massive heterogeneous IoT, spanning data from different types of connected equipment, such as sensors, veil systems, and mobile equipment. The need to perform AI-assisted monitoring in real time, where obviously latency takes an important stage here in order, for instance, to get an alert in a timely manner. And finally, from the mobility and coverage continuity point of view, if we consider real-time monitoring equipment such as drones or other types of vehicles, it is important to ensure that their connectivity is continuous and with sufficient quality of service according to the requirement and the context. So in this way, the Portuguese pilot has been organized in 7 planned trials, 3 of which already took place, and I will present shortly. The testbed spans multiple sites across the maritime port itself, the academic campus from IT Aveiro, and mobile sites for providing specific capabilities. We have a rich stack in terms of 5G core platforms, SDN and NFV orchestration. And importantly, this testbed has been and is being extended through the project by including other projects results, such from Imagine Beyond 5G, a custom NEF instance, dynamic slicing management capabilities, and across the project also the important inclusion of CAPIF. We also obviously consider the integration of the triadic 6G apps as an extension to the testbed itself. So from the point of view of key innovations, we can highlight the inclusion of 5G New Radio RedCap for the important role of providing an efficient communication radio in this case, for energy neutral sensor nodes. Event-driven QoS activation for drones and other types of unmanned vehicles, such as boats. The on-the-fly network slice management for energy efficient infrastructure operation, and edge analytics for processing vehicle-related data for the object detection or for detecting the hazmat trucks plates. And finally, the user equipment geolocation-aware smart lighting and context-aware EV charging. So looking at the first trial, which took place in February, the key goals were mostly to provide as in a proof of concept and demonstrate the 6G app triadic interfaces in the context of the first scenario, so environmental quality monitoring, and obviously showcase the expected benefits from the point of view of this scenario and the needs from the port. We've collected the interesting stakeholder mostly from academic and R&D community, and which for instance allowed to improve the positioning of the solution as in the context of early warning platform, and not only from a monitoring perspective. The second trial took place in March, and it focused particularly the demonstration of the second scenario, addressing safety and the hazmat truck detection. It also aimed to present and provide already early feedback on the intended contributions on the third scenario. And here we collected feedback from the stakeholders, both from the safety monitoring perspective, mostly given the in loco demonstration, but also already from the third scenario, so on the infrastructure energy management perspective. And here, one of the key takeaways was also the framing of the solution for the third scenario around renewable aware infrastructure management. So beyond the simple energy reduction goal. Finally, the third trial took place last week. So here the goal was actually to provide a first global demonstration covering all the scenarios. So in a way, demonstrating the global or wide the port monitoring capabilities covering the 3 dimensions and collect feedback from additional stakeholders, particularly other ports and regional and even public authorities. And here we equally collected some feedback, which is preliminary. It is still in the process. Actually, all the feedback itself, it will go through a strong digestion process in order to improve the upcoming stage of trials. And here one key takeaway is that the advanced beyond 5G and 6G enabled monitoring solutions have a strong potential to support not only the port end users operational response, but equally to strengthen public authority coordination. So there was clear interest from some public authorities to benefit from some of the data. Looking from the KPIs and KVIs perspective, I will only highlight the KVIs here. So spanning from these technical performance indicators and looking from the different scenarios perspective. So the first scenario has the particular potential to address or improve environmental incident detection and prevention, the IoT device lifetime, leveraging RedCap and intelligent QoS management, and also improve environmental monitoring coverage, leveraging the ad hoc or on-the-fly trigger the vehicles for monitoring particular cases. The second scenario has a potential to improve the energy consumption of infrastructure, particularly network and compute infrastructure, as well as road safety incident detection and prevention. So in the port surroundings, not only the port. And finally, the third scenario has a good potential to address the improvement of energy consumption of overall infrastructure. And here we are talking more broadly from even from a smart city or campus point of view, taking the best of available artifacts such as EV chargers, renewable energy, smart lighting, and so on. So just to conclude, and given the time constraints, we have already been able to validate some interesting results in a preliminary manner. And from a cross-trial perspective, there are certainly some lessons learned with respect to the planning of the trials, given the fact that there was an intense period of trials in a short period, as well as in the way that we should communicate to the stakeholders, especially non-technical stakeholders. So this is it from our side. Thank you.
Thank you, Sergio. And the last pilot, the Spanish pilot, and Javier Rivas from the University of Malaga will present that.
Hello, Sana. Hello, everyone. And this is Javier Rivas from University of Malaga, representing the Spanish pilot. Spanish pilot is composed by a number of companies, including University of Malaga, CSIC, which is the public research entity, Telefónica, the mobile operator, HP, which is a testbed provider of the core network, Nokia, which provides immersive remote driving technologies, Setaqua and Hydraulia as water utilities and water research center, and Keysight Technologies as a Tier 1 test and measurement provider. So the Spanish pilot is focused on the smart agricultural use case, and particularly also putting emphasis on the use of reclaimed water to help preserve the use of fresh water. As everybody knows, agriculture is a very challenging activity, and there is an increasing competition, as everybody knows, from different markets, and farmers are under a strong pressure. So in our pilot, we are putting emphasis on evaluating technologies to make farming more competitive, and enabling also research conducted in the La Mayora Research Farm, which is a scientific entity to produce new competitive crop varieties. So in terms of objectives, we focus on efficient farm operation using remote and immersive operation of vehicles and devices, and enabling like monitoring of control cameras, sensors, and appliances of different kinds. Similarly, we address the end-to-end life cycle operation, since the water treatment in the water treatment plant of Roquetas in Almeria, and until all the end-to-end water quality monitoring and irrigation decision system. The kind of requirements we target in terms of sustainability and beyond 5G connectivity involve pervasive coverage to ensure like we are able to deliver and share the information and assets and the water quality with farmers, and that we ensure low latency communication so that vehicles can be remotely driving with safety, like ground vehicles like AGVs or drones, and that we have fair bandwidth to enable rich use cases, like not only measuring like sport data from sensor, but also rich multimedia monitoring from cameras and other information sources. And also we target to have an accurate energy traceability so that we monitor the energy footprint of the different components of the network. And we enable future benchmarking and optimization. The test bed is focused on building on top of the evolution of the Victoria network test bed from the University of Malaga, that over a number of projects has been evolving, including multiple locations like the city center, the technology park, the police control center. And in this project, we are relying on the use of the network deployment and the La Mayora Research Fund, and also we will be conducting trials in the Roquetas water treatment plant. In the capabilities we have range from the live network deployments to the use of drones and state-of-the-art measurement tools. And we also, in the later phases of the project, we also include like capabilities we have in roadmap, like satellite connections. And some of the key innovation we have in these projects is like the use of interactive immersive remote driving, like that provided by Nokia. We have also like optimized network deployment to increase the uplink capacity to enable the flow of information from camera sources. Keysight is also contributing a network digital twin that we will be validating as part of the project to ensure we have accurate coverage maps from the farm. And we also like enable edge driving, emasculation, and AI training. We are integrating robotic arms for operation in the farm, and we are using 5G drones to create 3D coverage maps of the different areas of the farm, and including also like very accurate energy profiling of core network and mobile devices. I will be very short as we are little short in time. So we can see that in the farm we have a dedicated network deployment, a 5G private network using commercial equipment from Nokia. And we have conducted so far 2 trials. One is in February, where we located in the Malaga University campus in our research facilities, where we targeted a research audience, and we demonstrated the early phases of the project, ranging from the use of energy profiling of mobile devices and the core network using state-of-the-art power analyzers in combination with network emulators like the UXM or the load core to characterize the core network. But also with introducing the early phases of the project and the development we are doing, like the P4 software-defined networking UPF component, on the information integrated sensors and communication, and that we are also will be validating later in the project, and on the multi-connectivity and the use of robotic arms. We saw a strong interest from stakeholders, and we collected relevant feedback. The second trial we conducted on March in La Mayora farm, and we focused on the demonstration there in the validation of the remote driving use case. We had a very relevant audience of more than 50 attendees from a wide range of stakeholders, from farmer associations, including regional government representatives, agriculture companies like Trops, which is have a strong presence in the region, and also from different research groups. So it was very well attended. So we successfully validated the use of the remote driving and collected relevant feedback from the attendees. Very short, it's coming soon. The next trial we will be conducting that will be happening during UCNC. So everybody is invited to attend. It will be happening in Jan the 2nd. And we will be there validating the use of robotic arms and other technologies that we will be introducing, like the use of digital twins. And we will also share the progress we did on the remote immersive driving. So still there are some places available if some people want to join when attending the conference. And to end, we have highlighted a few representative metrics that we have added, like network capability, like throughput, latency, and so. But also we are adding like very relevant energy aspects, as we introduced it before, like characterizing the core network in detail, so that one of our goals is to produce a energy-aware realistic digital twin, so that we can predict the consumption of the different network components. No? And as we said, we also have a strong focus on water efficiency, so that we target to measure how much water we are saving by reducing the use of fresh water, by introducing rootline water in the water mix. No? And we want to measure how much productivity we obtain by the use of the different technologies we're introducing for the remote operation. So that's all from the Spanish pilot. Thank you, everyone.
Thank you, Javi. Maria, now we can pause the recording for questions and answers.
So the training program is presented here. You can either go in a full pathway that is equivalent to 2 credits and an approximate time of 60 hours, or you can just enroll in any of the courses that best suit your role or your profile, your academic or professional profile. So far, we have implemented the first mini course related to 5G fundamentals. The last one related to innovation and entrepreneurship is ongoing and will be also released soon, and will help also the accelerator program that will be commented later by Maria. And then pending 2 mini courses are related to the vertical, so they will be developing the second phase of the project. So our invitation for us is to join as early as possible, so that you don't just listen to the pilots, but also try to understand how they have been designed and how are they being evaluated. The learning loop here is quite simple, quite easy to understand. You just start by learning the concepts, apply it to a practical scenario, also create some evidence to a similar scenario, but working on your own, and try to reflect that on some sort of case or final feedback. So for us, it is important here that you join as early as possible, so that we can get this feedback and apply that to the pending courses we want to also develop. So just to provide you a sort of hint about how to engage on the course, the process is quite easy. You just go to our Moodle platform, to our learning platform, just log in. You can create your own account, and after acknowledging our privacy notice and filling in the personal data for that and verifying your mail, you will be able directly to enroll on the course. Right now 1, but in the end there will be 4. And once you are in this course, you can see that the structure is quite easy to follow. Each course is created or built on top of units, and units on top of lessons. So, and in each lesson, you will find a mandatory material that provides the essential part, whereas you will also be able to find optional resources and material in case you want to deepen your understanding, and also include also practical work here. And that's all from my side. In case you are interested to join this training program, you can just do it, and stay tuned to our website and promotional channels that we will be launching in the next weeks. Thank you.
Thank you, Benjamin. And then about our 6G Venture Accelerator program, as Benjamin said, on our 6G Versus website, you can find more information and links to both of these programs.
So last but not least, really quickly, trying to bring all these findings, all these learnings to the business world, empower small and medium enterprises and startups with the use of the learnings that we have from 5G and beyond, and 6G technologies, and the work that has been done with the pilots. Really quickly, I think you can, yes. Yeah, we are in search of 25 startups. The 6G Versus Venture Accelerator is an 100% online acceleration, business and technical acceleration program. And we're leveraging emerging 6G technologies for sustainability and business applications. It will be all done via Microsoft Teams, live, a combination of live and on-demand sessions. We will also use as an onboarding the learning platform that Benjamin presented, and we'll provide toolkits and mentoring sessions to the startups and businesses that will be participating in the program. What we offer, as mentioned, is technical and business workshops. We will provide tailored mentoring, training, technical validation, and feedback on the solutions design. Either it's under development or have been already designed. And we also provide strong investor readiness and exposure to the investors' ecosystems through the final pitching event. What we've been doing all these years is supporting startups reach investment readiness. They also have access to the 6G Versus architecture, pilot environments, and going on. It's a great network of industry experts here and the consortium of the project. It's a 10 weeks business and technical acceleration starting in September. With a combination of 4 technical workshops on 6G Versus architecture and use cases, 6G technical enablers and KPI, KVI literacy, testbed exposure, and a technology validation, and sustainability and ESG framing. And on the business workshops, we go from the problem framing and the market definition and how it's validated in the market, business model canvas and the value proposition. So the business really understand their USP and address the market with the service that is actually needed. And then we support them bringing that into the market with sales and marketing management and customer journey map. And then, as mentioned earlier, we prepare them through a pitching masterclass and with their working on their investment strategy to reach investment readiness, if this is something that is according to their strategy. Otherwise, we provide them insights on the EU funding landscape. The applications are now open. Here you can scan the link to the applications, but I will also share the site here in the comment section of the venture accelerators. You can have access to the open call guide, The application is pretty simple. It's done online via Monday. It's a form where it's in 2 stages. You express your interest, you have a look into the application form if it's something that is interesting for you. And what the application is in 4 different sections, where we ask for the general information of the person applying, information about the company. It should be a business, and we also ask for more details about the solution, the alignment with the project and team capacity, and we require a pitch deck for the final submission of the application. So here in the Zoom chat section, I'm sharing the link to the full website of the Venture Accelerator. Now the timeline is the applications are open now until July 10th. We will be reviewing the applications until August 8th. The SMEs that will be selected will be informed, the whole applicants will be informed if they've made it or not in the 25 cohort of this acceleration. They will be notified by August 10th, and in September we will be starting the acceleration. In November, we expect the graduation and the final pitching event. We review the applications as we review any business that wants to participate in an acceleration program based on the sector relevance due to the sector specific venture acceleration, the team strength, the business readiness and scalability potential, because after this acceleration, we have a tailored scale-up program to further support these startups and more SMEs in the ecosystem. Funding readiness and program fit. So this is what the expert committee, we have a committee of juries that are experts in the industry, in the business and 5G and beyond, to review these business plans, and we'll be looking at these criteria. We have a guide, the open call guide, on the website of 6G Versus, of the project, where it takes you step by step on the application process, what the project is about, the accelerator information, what are the benefits for startups and SMEs, timeline, selection criteria, technical details, terms and conditions, and any useful links to better help you consider if this program is right for you. Here is our contact information for technical support, or you can fill in the contact form on 6G Versus website and the link to the application form. But if you follow this link here in the chat, you will have access to all this information and, of course, the application link, or scan the QR here on your screen. So yeah, that's pretty much it about the accelerator. I want to keep it short for everyone, and happy to answer any questions you want either here or later on through the email shared earlier. Thank you.
Thank you, Maria. And then just to show what we will have after this webinar, in a week we will be in Malaga, in EU CNC, and we are well visible and loud there. We will have a booth with 3 demos and also La Mayora site visits, as Javi just invited everyone to visit there. We have 1 paper, 1 poster. We participate in workshops and panel discussion, and also we will have information on social media about our experiences and presence in EU CNC. And this webinar series will continue. Our next webinar will be on sustainability framework and impact. That will most probably take place in June. We will inform you about the exact date and how to register. I thank the audience and all presenters, and have a good Tuesday afternoon. Thank you.
Bye.
Thank you, Sana.
Bye, Sana. Bye.
Thank
Bye
you.
all.
Thank you.
Thank you all.
Thank
Thank
you.
you.